All right, guys, I want to go over those challenge questions with you for today's math work. In the first portion, I have you guys comparing two different things. I have you comparing fractions, and then I have you comparing decimals. So looking at the fractions, we have a fourth and we have 25 hundredths. And remember, sometimes it's a lot easier when you write it down. Okay, so we have 1/4 versus 25 hundredths. 1/4 over 25 hundredths. And then remember, when you compare fractions, you can multiply across. And 100 compared to 100, those two are equal to each other. So we know the first answer is equal. So we know it's going to be one of these two. Now we're on to the second question. We have 3.51, and we are comparing that to 2.99. And there's a third 9. Remember, this is the same thing as a mixed number. 3 and 51 hundredths compared to 2 and 999 thousandths. It's very clear to me when I turn it into that and I show students that it's a mixed number. This is smaller than 3 by 1/1000th of a piece. This one's bigger than 3. So therefore, that is your answer. Okay. Let's look at the second one. We have 87 and 89 hundredths. And we could then take away 9 and 58 hundredths. Now remember, you have to make sure that the decimals are lined up. 9 minus 8 is 1. 8 minus 5 is 3. You have your decimal. 7. You cannot take 9 from 7. Therefore, we have to borrow. And 17 minus 9 is 8. And 7 minus nothing is 7. So that's 78 and 31 hundredths. Now we have a third of 37. So we have 1/3 of 37. We have 1/3 of 37. And the only way to multiply fractions is by turning them both into fractions. You cannot multiply a fraction in a whole number. 37 times 1 is 37. 3 times 1 is 3. Now you have a whole bunch of holes in here. How many 3's are trapped into 37? 12. How do I know? Because I can count by 3's. 10 of them's 30, and then 11's 33, and 12 is 36. So 36, there's still one left over. So it's 12 and 1/3. Perfect, wonderful, grand. All right, 12 and 1/3. And then this question. Oh man, this is the one. This is that question where students were like, Mr. Stahl, for real though? Okay, we have a bunch of students. We have some students wearing just gloves. We have some students wearing just jacket. We have some students wearing both, like great, wonderful, warm students wearing jacket and a glove. And then we have a couple students not wearing anything. So the first thing you want to do in questions like this, try to understand your information, okay? So let's understand 14 total students, okay? We have 7 total wearing a jacket. We don't know how many of those are wearing just a jacket. We have 6 total wearing gloves. Of these students, okay, of these students, so this is your total, of these students, you have 3 wearing both a jacket and a glove. So what we actually want to do is we want to start with these students, right? Let's draw them. 1, 2, 3, and I'm going to put JG on all those. There's still 11 students left, right? We have 7 total wearing a jacket. So we have 1, 2, 3 there wearing a jacket. How many more do we need wearing a jacket? Well, 4, because we have 7 total wearing a jacket. So these guys must be just wearing a jacket. And then we have 6 total wearing gloves. 1, 2, 3. Still have to add 3 more because they're just wearing gloves. Guys, drawing pictures helps so much, right? The only other thing that we know is just 14 total students. Right now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many knuckleheads are not wearing jacket or gloves? 1, 2, 3, 4. Therefore, that answer is 4. Let's see how I did. All right. No errors. Perfect. Watching this video was not mandatory. So the fact that you did means you are on the right track this year to doing really well in math, because you are choosing yourself to try to understand why you got it wrong. And it takes, those are the students that I see every year that just excel and do so well. So good for you. All right. Thanks for watching.